All right, we're back. All right, so for question number 6, we're continuing on with the chain rule. But in today's videos, remember what we're looking at is, well, what if we are multiplying two functions together? For example, in question number 6 here, we're multiplying the tangent of 4x times the sine of 5x. Well, we know that in the big picture, this is going to be our product rule. But each one of these has a chain kind of built into them. So when we take that derivative, we're going to be thinking product rule, which says take the first function, which is just the tangent of 4x times the derivative of the second. Remember, it's f g prime, right? Which is going to be cosine 5x. But remember, because I have something inside, I'm using my chain rule. So I have to multiply that by 5. Plus, now we're going to take the second function, which is the sine of 5x. Remember, now we're doing g times f prime. And the derivative of tangent, that is our secant squared of 4x, of x. But remember, we're taking the derivative of tangent of 4x. So we do have an inside. I got something inside parentheses here. So we have to use our chain rule. And we multiply that by 4. And there is our derivative. Very easy to do. All right. Now, let's take a look at the hardest one you're going to get. Number 7. This one's hard mainly because we're going to get a negative exponent here. And it's not going to be in a very nice place. So, let's take a look. So to solve something like this, I'm going to do something I'm not really a big fan of, but I am going to rewrite this. X over, and this is going to become x squared plus 4 to the 1/3. Now notice, what's my big picture here? Is quotient rule. So when we take the derivative, that's big picture. We do have a chain rule right here. But when we take that derivative, we will get f prime of x equals. And this isn't going to look nice. I'm going to leave a little bit of space here. Low d high, which is just 1, minus the top. When we take the derivative of the bottom, this is where it gets pretty nasty. We get this negative 2/3. And we're going to multiply that, be careful, chain rule, by 2x. And on the bottom, we're just going to square that. We will get x squared plus 4, 1/3 squared. This becomes, becomes 2/3. All right, there's our derivative. Now, don't forget this 2 right here. That comes from the chain. That's the inside derivative. So what I'm going to do right now is I am going to rewrite this whole quantity right there. And like so. And this is going to become as a fraction x squared plus 4 to the 1/3 minus, on top I have this x and this 2x. So I can just write that as 2x squared. But on bottom I'm going to have this 3 times x squared plus 4 to the 2/3. On the same thing on the bottom is just left alone. No negative exponent. Now it looks really bad. It does, but I have an LCD. We've seen this before. I can multiply by my least common denominator, and that's this 3x squared plus 4 to the 2/3. But I got to do it to the bottom as well. 3x squared plus 4 to the 2/3. And the reason I do that, when I distribute over here, what I'm left with is just this x squared plus 4. I have a 3 there, because I'm multiplying by 3, and I got this 2/3 and this 1/3. That just becomes a 1. Minus, but this is the beauty of it. When I distribute to this one, it cancels. So I'm just left with this 2x squared there. And then on bottom, I'm going to be left with 3, and I'm going to get this x squared plus 4, 2/3 and 2/3, that's just 4/3. No negative exponents, no complex fractions. There's your answer. You can clean up the top a lot if you wanted to. You can clean up the numerator. This is 3x squared minus 2x squared, so we just get x squared plus 12 on top over all of that if you wanted to. It's a neat skill to have. So let's try with number 8. Now, of course, number 8 is going to be a little bit more trickier. Okay, so when we take the derivative, again, I'm going to rewrite this. I'm not a big fan of radicals. I'm very conservative in my life. Then we get this 1/2. When we take the derivative, our rule says take the bottom function. That's this 1 plus the cosine of x to the 1/2 times the derivative of the top, which is just cosine of x, minus the top sine of x. And now I got to take the derivative of the bottom, and this is where it gets pretty ugly here. Ready? We get 1/2, 1 plus cosine of x to the negative 1/2. But it's a chain rule. I got to multiply that now by a negative sine of x. Ooh, I way ran out of room there. All over the bottom squared, which is if I square a square root, I just get 1 plus cosine of x. All right. I don't like this because I have that negative exponent here again. Remember, that was a negative 1/2. Doesn't look like it, so maybe make it more negative there. So I'm going to rewrite it. One long fraction bar. The bottom is going to stay 1 plus cosine of x. But on top, I'm going to have this 1 plus cosine of x to the 1/2 times the cosine of x. Minus, and here's our part here. Here I can multiply the sine and this negative sign, and that's going to give me a negative sine squared of x. On the bottom, I'm going to have the 2 and this radical part. 1 plus the cosine of x to the 1/2. And now I am just going to multiply by my LCD. Well, what's the LCD here? That's just this 2. My LCD, I'm going to do it on this side this time. There's my LCD right here. It's just this 2 times 1 plus cosine of x to the 1/2. Same thing on the bottom. 2, 1 plus the cosine of x to the 1/2. And I'm just going to distribute that to all terms here. And let's see what happens. Over here, we're going to get 2 cosine of x. I have a 1/2 and a 1/2 times 1 plus cosine of x. Minus, over here when we distribute, this just all cancels out. And that becomes a minus and a negative becomes a plus sine squared of x. On the bottom, we're going to get this 2, and we got this 1 plus cosine of x. Well, this is a power of 1. That's a power of 1/2, so that becomes a 3/2 power. And there's your answer. Leave it alone. These are pretty ugly to do. These take a lot of practice. We're going to see these almost every day now. Okay, we're going to see them quite a bit. Okay, I want you to get really good at those. Those are the ones. If you're going to miss something, that's the one you're going to miss right there. I don't think I give you anything this nasty though. You know, I'm not heartless. All right. So number 9. Here we go. Take a look at number 9. Easy one right now. It's our product rule, of course. So when we take the derivative, I'm going to use dy dx because I use y. Our first function is x to the 4th times the derivative of the second. See, this is my big picture here is, of course, product rule. But when I take the derivative cosecant, I do have a chain rule. So we get negative cosecant 3x, cotangent 3x, chain rule, what's the derivative of 3x? Times 3. Plus the second, which is our cosecant 3x, times what's the derivative of the first? 4x cubed. And there's your derivative. Piece of cake. Easy peasy, right? Woo, that was a big one. All right, number 9. Oh no, it's our favorite one. It's a tangent line. And really our last example for, second number 9. It's our tangent line. These are fun. We like these, right? So we want to find the tangent line at the given point. So we need a point, which we were told is pi over 2, pi over 4. And next we need a slope. Well, to get the slope, we need our derivative. Well, let's take a look here. This, of course, is our product rule, which says take the first function, x squared multiply that by the derivative of the second. Now, when we do the derivative of the second, this is our chain. I tell you, this lesson's off the chain. The derivative of the outside is cosine. We leave that inside alone. Now, our chain part, we're going to multiply by 2. Plus the second, which is the sine of 2x, times the, and I like to put that in parentheses, times the derivative of the first, which is also just 2x. And now to get the slope, we're going to plug in our x value, which is pi over 2. Pi over 2 squared, pi over 4. Plug in here, we get the cosine 2 times pi over 2 times 2, plus the sine of 2 times pi over 2 times 2 times pi over 2. And simplifying here, we should be able to know this. Pi over 4 times, those cancel. Cosine of pi is negative 1 times 2. Sine of pi is just 0, so that whole term is just 0. So what are we left with? Negative pi over 2. And there's our slope. So my tangent line, y minus pi over 4 equals negative pi over 2, x minus pi over 2. And there's your tangent line. I do have one more down here. It's kind of a little fun one for us. This is like the mother of all problems. Oh, man. Let's try this one. Product rule, right? Oh, gosh darn it. So when we take that derivative, rewrite it. I don't like it like this. X cubed times the sine of 3x to the 1/2. So the derivative of the first, it's the first, we got product rule, times the derivative of the second. This is our chain rule, but not just once, but twice. Remember, we're nested inside this radical, this 1/2. Inside the 1/2 power, we have a sine, and inside that sine nested is a 3. So we have 3x. We have to take care of all of that. So this becomes 1/2 sine 3x to the negative 1/2. And I just keep going. This is where my chain starts. What's the derivative of sine? Cosine of 3x. The derivative of 3x, 3. We just keep on with that chain rule right there. When you take the derivative, you have a chain rule, you have to keep it going. Plus the second, which is the sine of 3x to the 1/2 times the derivative of the first, which is just 2x. Don't do all that beautiful work and forget that. Remember, no negative exponents here. So when we simplify it, well, not simplify it, obviously. On top, I'm going to get this x cubed, this cosine of 3x, and this 3. On the bottom, I'm going to get this 2 and the sine of 3x to the 1/2. And this all just stays the same. 2x, sine, 3x, all of that to the 1/2. Right there. And then the derivative. Whew! If you do that one, you're at God level. All right. Y'all have fun. I'll see y'all later. Bye-bye.